Okay, good evening. Comment box. Welcome back. So we are just doing some problems of first chapter, second chapter, and if possible, third chapter. Okay, good evening, all of you. I'm doing one problem from the first chapter. So I'm mixing up of first three chapters. And here the concept is law of quantization of charge Q equal to plus or minus NE. Lorentz electric force QE. Then F equal to MA, acceleration A equal to F by M. These are the concepts which we are going to use. See, let's see the question. A positively charged oil drop is prevented from falling under gravity by applying a vertical electric field of 100 volt per meter. If the mass of the drop is 1.63 into 10 raised to minus 3 gram, find the number of electrons. You have to find out what number of electrons. Now let's see. A positively charged oil drop prevented from falling under gravity by applying a vertical electric field of 100 volt. So let E equal to 100 volt per meter. Mass of the drop is 1.63. Mass is given as 1.63 into 10 raised to minus 3 gram. That is 1.63 into 10 raised to minus 3 into 10 raised to minus 3 kilogram. That is 1.63 into 10 raised to minus 6 kilogram. Okay. Now, I know that F equal to MA and the Lorentz electric force, which is the force experienced by charged particle Q in an electric field, E is what? QE. So, MA is equal to, so here, what is the force QE? So, I know that mass of the drop is given, find the number of electrons. So, mass of the drop is given. So, when you balance that, no, MA equal to what? QE. Now, generally, equation is MA. Since it is falling under gravity, it has to be mg. mg equal to QE. But I know that Q equal to plus or minus NE. So, mg is equal to what? Plus or minus NE into E. See, suppose this is oil drop. Its weight is acting vertically downwards, which is gravitational force. And this oil drop is supposed to fall. If it is not falling, means what? There is equal and opposite electric field. That means gravitational force is balanced by Lorentz electric force. That is the reason why we have written mg equal to QE and QE equal to plus or minus NE. So we have to find out N equal to mg divided by EE. What is mass here? 1.63 into 10 raised to minus 6. Gravity is what? 10 divided by charge of electron is, we already know, 1.6 into 10 raised to minus 19. And the applied electric field is what? 100 volt per meter. Any doubts? If you solve that, you will get the answer. And your answer will be 10 raised to 12. Answer will be 10 raised to 12. Since it is a number, there is no unit. മനസ്സിലായോ? മനസ്സിലായോ? Is it clear? Anas, മനസ്സിലായോ means is it clear? Anas, Sweda. I will teach you some Malayalam also. Noted? Note ചെയ്യാട്ടോ. And once you finish noting, please say noted. Okay. Kabilan, yeah, Kabilan is there. Actually, Kabilan was requesting me to speak in English. I think more students are there, so I will speak more English. Yeah, done. Noted. Finish. Finish noting now. Next question. Next question. A pendulum of mass 80 milligram carrying a charge of 2 into 10 to the power minus 8 coulomb is at rest in a horizontal in a horizontal electric field of 2 into 10 raised to 4 volt per meter. Find the tension in the thread of the pendulum. Find the tension in the thread of the pendulum. And the angle it makes with the vertical. So let's see. This is the pendulum. I hope you remember about pendulum. This is the pendulum. Pendulum of mass 80 milligram. Okay, no problem. That is mass is equal to 80 into 10 raised to minus 3 gram. Okay. Carrying a charge of 2 into 10 raised to minus 8. So charge is equal to 2 into 10 raised to minus 8 coulomb. At rest in a horizontal electric field. So electric field is given 2 into 10 raised to 4 volt per meter. Okay, no problem. Find the tension. So I have to find out T equal to question mark. T is not time, T is tension. Thread of the pendulum and the angle makes with the vertex. So this is the initial position. Now, if there is horizontal electric field, what happens? This pendulum will move in the direction of electric field. So this is the initial position. Now it is an angle theta with the initial position. And this is what? Tension T. This is what? Tension T. And if this is theta, this also has to be theta. Alternating near angle. If this is angle theta, then this has to be what? T cos theta. And this has to be what? T sin theta. Resolving, what is the concept here? Resolving vector into individual rectangular components. See, mass weight of the pendulum will be acting vertically downwards. There is tension T which acts towards in this direction. Since this angle is theta, this also has to be theta, alternating near angles. If this side is making an angle theta, you know that when you resolve a vector into rectangular components, the side which make an angle will be cos component and the opposite component will be what? Sin component. The horizontal component is cos component and vertical component is what? Sin component. Now we can see that mg, the actual weight mg is balanced by what? T cos theta. T cos theta. See, and T sin theta balance what? Lorentz electric force, that is Fe equal to QE. So T sin theta is equal to what? QE. So let this be equation 1 and let this be equation 2. Equation 1 by equation 2 means what? QE by mg is equal to T gets cancelled, sin theta by cos theta, tan theta. So what is Q? What is Q? Charge is what? 2 into 10 raised to minus 8. What is electric field? 2 into 10 raised to 4 divided by what is mass? 18 into 10 raised to minus 3, and gravity is what? 10. 10. So it becomes what? 2 becomes 4. Divide here, 80 by 4 is what? 20. So how much you get? 10 raised to minus 8 to 10 raised to 4. It becomes what? 10 raised to minus 4 divided by 20 into 10 raised to minus 2. 10. So that means what? 0.2. That is 10 raised to minus 4 divided by 2 into 10 raised to minus 1. That is 1 by 2, 0.5 into 10 raised to minus 3, right? I think that is the angle we will get. 2 into 10 raised to minus 4, 20, 80, 20, then 10 raised to minus 4, then 10 raised to minus 2, 20 into 10 raised to minus 2 means what? 20 by 100, that is 0.2, that is 2 into 10 raised to minus 1 becomes what? 2 into 10 raised to plus 1. So 1 by 2, 0.5, 0.5 into 10 raised to minus 3. Any doubts? Any doubts? So tan theta equal to this much. Yo, no, there is a problem here. There is a problem because there is a mistake from my side. This is 10 raised to minus 3 gram. So it has to be 80 into 10 raised to minus 3 into 10 raised to minus 3. That I forgot. It becomes what? 80 into 10 raised to minus 6. So there is a mistake. It has to be 80 into 10 raised to 80 into 10 raised to minus 6. Then the whole volume changes. 10 raised to minus 4 divided by 20 into 10 raised to minus 6, 10 raised to minus 5. So 20 into 10 raised to minus 5. So 10 raised, that is 1 by 2 into 10 raised to minus 4 divided by 10 raised to minus 4. So that gets cancelled. 1 by 2 is what? 0.5. So tan theta is equal to what? 0.5. Then theta equal to what? This is the angle. Theta will be tan inverse 0.5. But in order to get this tan inverse, you have to use scientific calculator. But as an entrance problem in the options, you can see tan theta equal to 0.5. And if you are using scientific calculator, you will get the answer 27 degree. Any doubts? Now, so theta we found out. Then we can substitute the value of theta to any case. So, mg is equal to t cos theta. So, t is equal to mg by cos theta. M is what? 18 to 10 raised to minus 6 into gravity 10 divided by cos 27. Cos 27, again you have to use what? Scientific calculator. Then if you solve that, you will get the tension as 8.81 into 10 raised to minus 4 Newton. If you solve this answer using scientific calculator, you will get the answer 8.81 into 10 raised to minus 4 Newton. Agila, good evening. Now only you joined. Any doubts? It's simple, right? 4 root to 5 maybe. Any doubts? Anybody? Any doubts? Please note it down fast. All of you noted. Next question. A slab of material of dielectric constant K has the same area as the plates of a parallel plate capacitor but has thickness 3D by 4 where D is separation between the plates, where D is the separation between the plates. How is the capacitance changed when the slab is inserted between the plates. The slab is inserted between the plates. See, we know this from second chapter. Capacitance of a parallel plate capacitor is what? Epsilon 0 A by D. If the gap between capacitor plates completely filled with the dielectric slab, the formula is epsilon 0 epsilon R A by D, or some teachers write epsilon 0 K A by D, because epsilon R can be represented either by K or epsilon R. Where epsilon R is the dielectric constant. Now, when a dielectric slab is inserted, capacitance formula is epsilon 0 A by D minus T plus T by K, where T is the thickness of the dielectric slab And when the conducting slab is inserted, the formula is epsilon 0 A by D minus T. When the conducting slab is inserted. Now let's see what happens here. See, we should draw a figure. This figure tells you that this capacitance is C1 and there is a shaded portion of capacitance C2 which is having dielectric constant K. Which is having a dielectric constant K. So this is the case. This is the case. A slab of material of dielectric constant K has the same area as the plate of a parallel plate capacitor but has thickness of what? 3D by 4. Where D is the separation between the plates. The separation between the plates is what? D. Now remember, the wall distance is what? D. How is the capacitance changed when the slab is inserted between the plates? Now first of all, you have to thoroughly understand the question. A slab of material of dielectric constant K. So what is the dielectric slab, dielectric constant K? It has the same area as the plates of a parallel plate capacitor, but has thickness is what? What is the specialty of this parallel plate capacitor? Thickness is what? 3D by 4. Okay, where D is separation between the plates. How is the capacitance changed when the slab is inserted? Now, if this distance is D by 4, then this distance will be what? 3D by 4. Now, when the plate is filled with air, what is the capacitance? Epsilon 0 A by D. Remember, capacitance of a parallel plate capacitor, when the gap between the plates is filled with air, what is the formula? Epsilon 0 A by D. Now, what happens here? What is the specialty in this question? Slab of material of dielectric constant K has same area as the plates of a parallel plate capacitor, but has thickness is what? 3D by 4. So, this dielectric slab thickness is what? 3D by 4. 3D by 4. And this area has the same area as the plates of a parallel plate capacitor, but has thickness 3D by 4. But this is separation. Now, there are two cases. One is dielectric slab that is having thickness 3D by 4. So, what is the remaining thickness? D by 4. Now, these two are connected in this manner means what? They are connected in what? Series. So, when here C1 and C2 are in series. When capacitors are series, what is the formula? What is the formula we should use? 1 by C is equal to 1 by C1 plus 1 by C2. So that is the formula for equivalent. Maybe I should write C dash, the total capacitance formula. Now 1 by C dash is equal to, now remember, what is 1 by C? 1 by C1 is what? C1 is epsilon 0 A by D, first case. A by D is a standard formula, but what is the gap here? D by 4. So, 1 by epsilon 0 A by D by 4. In second case, what is 1 C2? Epsilon 0 A by, what is the thickness here? What is the thickness here? Epsilon 0 A by 3D by 4. 3D by 4, but there is a dielectric constant K. So, there will be additional dielectric constant into K. So, it becomes what? C2 is equal to what? 4 epsilon 0 AK divided by 3D. I hope it is clear. Okay, in second case, the formula will be what? This will be the formula. So, instead of 1 by C2, I should write, 1 by C2, sir. For 1 by C2, I should write what? Epsilon 0 AK divided by 3D by 4. So, if you solve that, how much you will get? 1 by epsilon 0 A by D by 4, right? So, it becomes what? So, 1 by, first case, 4 epsilon 0 A by D. Here 1 by, first case it becomes what? Instead of C2 it becomes what? 4 epsilon 0 AK divided by 3D. So that D moves to the numerator. So D by 4 epsilon 0 A plus 3D by 4 epsilon 0 AK. So this is the way we will get that. So now in this equation, D by epsilon 0 A is a common thing. D by epsilon 0 A is a common thing. So if you take that D by epsilon 0 A as common, it becomes what? 1 by 4 plus 3 by 4K. What is epsilon 0 A by D is what? C0. So D by epsilon 0 is what? 1 by C0 into 1 by 4 plus 3 by 4K. 1 by C0 into 1 by 4 plus 3 by 4K. Or I can take, since it also have C4 common, I can take 1 by 4 C0 into 1 plus 3 by K. So this is the answer we got. Now you can solve that. So 1 by 4 times C0, if you take LCM, it becomes what? K plus 3. So 1 by 4 C0 into 1 by 4 C0 into 3 plus K by K. This is the answer. Not clear. Thank you. I know it's tough. It's not coming down. It's a JEE main. Let me write this also. It's JEE main 2021-22. Both are the same question game, 21 and 22, and CBSE question paper also. See, here the point is that first there is a capacitor that is having air. In that case, Navaneet, what is the formula for capacitance? Epsilon 0 A by D. That is the original case. So, first there was a capacitor having a plate separation D, and it is having capacitance of what? C equal to epsilon 0 A by D. I am calling it as C0, which means what? This capacitor plate is having air between the plates. That is C0, epsilon 0 A by D. Yeah, okay. Wait. Now, a slab of material dielectric constant K. Now we are bringing another slab. That slab is having a dielectric constant K. It has the same area as the plates of a parallel plate capacitor. So, second case, area is same. It is having a dielectric constant of K. How is the capacity? Now, we D separation between the plates. In that D separation between the plates, how is the capacitance changed when the slab is inserted between the plates? This is the original figure. In second case, there is another capacitor having capacitance of what? In this case, what will be the capacitance? This is the first case. In this case, what is the capacitance? Epsilon 0, epsilon R, or you can write K. Area is same, but what is the distance? Distance is what? Between the plates is what? 3D by 4. What is the distance it is having? 3D by 4. As the thickness of what? Thickness of what? Its thickness is given that 3D by 4, where D is the original plate. Now these together, this is inserted. So it will be taking time. The first capacitor C0 is equal to epsilon 0 A by D. Then this is having plate separation D, and it is having air between its plates. Now there is another capacitor. Let it be C. Okay, in the first, okay, in our note, okay, this is the second case. Here, epsilon 0, it is having a dielectric constant K, area is A only. But what is the separation between the plates here? D by 4. Not D by 4, 3D by 4. So, original gap is D. Now, there is another capacitor with the dielectric slab 3D by 4 and area is common. Both are having same area. But what is the gap between them? 3D by 4. This is inserted here. So when you insert a dielectric slab or capacitor having dielectric constant K and a separation 3D by 4, how much is left here for air? Earlier, air was in the wall width D. Now out of the wall width D, 3D by 4 width is occupied by capacitor having dielectric constant K. So in the first case, let this be C1 and let this be C2. C1 is having air. So that is what C1 capacitance is what? Epsilon 0 A by D, D by 4. Why D by 4? Because original gap was D. Out of this original D, 3D by 4 is occupied by this new dielectric slab or new capacitor. So how much is left? Original D minus 3D by 4. So that means what? LCM is 4. 4D minus 3D by 4. That is equal to D by 4. So now the original capacitor which is having air is only at a plate separation of what? Epsilon 0 A by D by 4. And this one is having a capacitance of what? It is at a width of 3D by 4. So it is having capacitance of what? Epsilon 0 K into A divided by 3D by 4. I hope up to this much is clear. Is this concept is clear? Not clear. Sir, appo this C epsilon 0 A by D plus yeah, you can give that. You can give that equation. You can use that equation. You can use that equation. Now these two capacitors, how they are connected? How they are connected? Now they are connected together, right? So this is C1, this is C2. So they are connected together. So total capacitance will be what? Total capacitance, it's a series combination. So 1 by C is equal to 1 by C1 plus 1 by C2. But what we have here, we are having what? C1 and C2. Just wait a second. So 1 by C1 plus 1 by C2. Then somebody was asking why 1 by C. 1 by C means what? It is capacitors in series. So you have to use the series combination formula. 1 by C is equal to what is 1 by C1? 1 by C1 is what? Instead of C1 I should write what? Epsilon 0 A by D by epsilon 0 A by, instead of D I should write what? D by 4. So it becomes what? 1 by C is equal to 1 by this 4 moves to numerator. So epsilon 0 A by D. And in second case, instead of 1 by C2, what I should do? 1 by epsilon 0 Ka divided by, instead of D I should write what? 3D by 4. So it becomes what? It becomes what? 1 by 4 epsilon 0 Ka by D by 3D. Now what happens? 1 by c is equal to this d moves to what? Numerator. See, this moves to numerator, right? So 1 by c is equal to what? D divided by our formula. That we have done that previously. From there onwards, you can see that d divided by 4 epsilon 0 a, then it becomes what? 3d divided by 4 epsilon 0 a k. Then we are taking d by epsilon 0 a common. Any doubts? Any doubts? Just note it down. Done. Noted. Rest is same only. Scroll up. See, it's a tricky one. It's a lengthy one, but it's okay. You can do it. Done. Finals ഇത്രയേ ഉള്ളൂ. 1 by 40, 3 plus k by k. That is the final answer. No. Yeah. This is 1. Sharanya, this is 1 by c dash. We are calculating 1 by c dash. What is our requirement? 1 by c. See, we should get new capacitance. So c should be what? 4c0k divided by 3 plus k. This will be the final answer because we were doing for 1 by c dash, right? So final answer should be 4c0k divided by 3 plus k. Please note it down. I hope you have done. Done, right? Done. Next, there will be Wheatstone type of problem. Last class we have seen Wheatstone type of problem, that Wheatstone is applicable to the capacitors also. See, this is 10 mu f, this is 10 mu f, this is 10 mu f, this is also 10 mu f, and the center capacitance is also 10 mu f. This is A, this is B. What is the capacitance between A, B? Please type your answers. Let this be 15 mu f. What will be the capacitance between A, B? Answer will be what? We know that. See, it is similar to Wheatstone. So let this be P, this is Q, this is R, this is S. So P by Q equal to what? S by R. That means what? Wheatstone balancing condition is satisfied. That means what? No charge. We will say no charge will be flowing through the middle branch. So upper two capacitors are connected in series. So it becomes what? It becomes what? If they are in series, it becomes what? 10, 10. Answer becomes what? 5 mu f. And the lower two are also in series. So lower also capacitance is what? 5 mu f. 5 mu f and 5 mu f are in parallel. So answer will be what? 10 mu f. Any doubts? Now without this idea also you can we can solve that if in Wheatstone type problem, if all branches excluding middle branch have the same capacitance, then total capacitance equal to what? Capacitance of any one branch. Done, right? Yeah, 10 mu f. Next question. What is the capacitance between A and B? What is the capacitance between A and B? This is our next question. What is the capacitance between A and B? Let this be 5 mu f. Let this also 5 mu f. Let this be 5 mu f. And let this also be 5 mu f. And this one be 10 mu f. What is the capacitance between A and B? See, when you get this kind of a question, first you have to do that. Just give values to the junctions. So let this be C, let this be D, let this be E, and let this be F. Then redraw it. So A to C, then C to D, then D to F, then what? C to one branch is to E, C to E, then E to F. Then between D and E there is a branch. Let this be, this is D, this is F, and this is E. Between D and E there is another branch. Now we came to know that it is what? It is a Wheatstone bridge with all capacitors having the same value, 5 mu. And the middle one is having 10 mu. So what is the total capacitance between A and B? We know that it is 5 mu. Any doubt? Done, right? Clear. So next question. 10 mu, 10 mu, 10 mu, and this is 30 mu. What is the capacitance between A and B? See, this is not Wheatstone. It's a special type. We call it a shorter type. So, for these three capacitors are in parallel. So, 10 mu and the next 10 mu and the next 10 mu are in parallel. And the whole combination is in what? Series to this 30 mu. See, this 30 mu is not included in this parallel combination. So, this is 10 mu, this is again 10 mu, this is also 10 mu. So, what will be the total capacitance of this combination? Since the capacitors are parallel, 30 mu. That is in series with another 30 mu. So, what will be the total capacitance? 30 by 2, 15 mu. Yeah, good. Note it down. Done? $15 million. Next question. X 2 mu, 3 mu, 5 mu, 10 mu. What is the total capacitance here? Now remember, these combinations are what called shorter combination. So what happens? 2 mu, 3 mu, and 5 mu are in what? Parallel. And the whole combination is in series to 10 mu. So, what happens in parallel? We can simply add them. 3 plus 2, 5, 5 plus 5, 10. So, 10 mu is in parallel with another 10 mu. So, what happens? Total is what? 5 mu. Any doubts? Any doubts? I hope it is clear. Done? No doubt. Next. What is the equivalent capacitance in this combination? This is 4 mu. This is A. This is B. This is also 4 mu. This is 4 mu. 4 mu. 4 mu. Now what happens? These two capacitors are in series. So equivalent capacitance will be what? Upper side it will be what? 2 mu. No, series. So series, yeah. So 2 mu. That is in parallel with the 4 mu. That is in parallel with the 4 mu. Now these two are in series. So what happens? It becomes what? 2 mu. So you get the combination like this. This is A and this is B. See what happened? The upper 4 mu are in series. So I have taken 2 mu. And this is also 4 mu. And here what? 4 mu are in series. So 2 mu. Now what happens? These all three are in what? Parallel. So what you have to do? Simply add them. So answer will be what? 10 mu. So not 10 mu, 8 mu. 8 mu. Any doubts? Any doubt? Any doubts? Please note it down. Next question. A platinum wire has a resistance of 10 ohm at 0 degrees Celsius and of 20 ohm at 273 degrees Celsius. Find its temperature coefficient of resistance. Find its temperature coefficient of resistance. Resistance of 10 ohm at 0 degree. So see, remember, reference temperature is always given lower temperature, that is 0 degree. And resistance at 0 degree is what? R0, that is 10 ohm. Then 20 ohm at 273. Higher temperature is given as what? T, which is 273. And resistance at a higher temperature is what? RT, that is 20. Now, what is the formula which connects them? RT equal to R0 into 1 plus alpha into T minus T0. This is the formula, where alpha is the temperature coefficient of resistance. So, we have to find out alpha. So, what are the data given? 20 RT and R0 is what? 10. 1 plus alpha into what is T? T0. T minus T0. T is what? 273. T0 is what? 0. So 20, 10, 1 plus 273 alpha. So 2 is equal to 1 plus 273 alpha. So 2 minus 1 is equal to 273 alpha. That is 1 equal to 273 alpha. So alpha is equal to what? 1 by 273. What is the unit of alpha? Per degree Celsius. Any doubts? Yeah. Please note it down. Done? All of you completed? Done. Okay. So next problem. Next problem. This is 1 ohm. This is also 1 ohm. Here also another 1 ohm. 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 This is A. This is B. Everything is 1 ohm. 1 ohm. 1 ohm. 1 ohm. And it is an infinite network. See, although the network starts from here, it goes to infinity. There is no end for this network. So I have told you how to solve infinite network problems in capacitors chapter. So whenever you get an infinite network problem, first of all, you should know the base of this network. On what base? What is the basic unit? So when you examine, you can see that this much is repeating and this is the base. These 3 1 ohms are the base and everything else is a repetition of these 3 1 ohms, right? It's a repetition of these 3 1 ohms. I hope that is clear. Again, I am reminding, first of all, find out the base. What is the base circuit and everything else will be a repetition. Now you can say the whole repeating network has the resistance of X ohm. So what is our task? We have to find out the resistance between A and B. That we have to find out. For that purpose, first of all we have to recognize the repeating section. Then that has the resistance of X ohm. And this is the original base section. So I am redrawing this as X ohm, the repeating one. Then what? 1 ohm. and here also, no, there is a mistake. This is X ohm, then 1 ohm, then another 1 ohm, here also 1 ohm, and here it is what? A, and here it is what? B. See, so this section X ohm represents the infinite branch, or not infinite section of this network is replaced by a single resistor of X ohm. That suggests that the infinite part has a resistance of X ohm. Okay, now when you examine, these two X ohms are in, X ohm and 1 ohm are in parallel. So you can simply add them. So it becomes what? 1 plus X. And here we have 1 ohm, and here also it is what? 1 ohm. So you can, it's a resistors, right? Resistors parallel means what? Resistors parallel means what? 1 into X divided by 1 plus X. That is X divided by R1, R2 divided by R1 plus R2, 1 plus X. So what is the resistance here? X ohm and 1 ohm are in parallel, no? So 1 into X divided by 1 plus X, it becomes what? X by 1 plus X. That is in series with these two 1 ohms. So what is the total resistance we will get? X by 1 plus X plus 2, because 1 ohm and 1 ohm are in series. I am redrawing this. See here, X ohm and 1 ohm are in parallel. So I am replacing it with the X into 1, that is X divided by 1 plus X. That is in series. So X by 1 plus X, 1 plus 1 is what? 2. See, X represents an infinite network. So whatever you are adding to infinity, you will get same X only. I hope that step is clear. It's a very important step. X by 1 plus X plus 2 is equal to what? X only. If you take LCM, 1 plus X, X plus 2 into 1 plus X equal to X. So X plus 2 into 1 plus X, X plus 2 plus 2X divided by 1 plus X equal to X. That is X plus 3X plus 2 by 1 plus X equal to X. That is 3X plus 2 equal to 2 in X into 1 plus X. So 3X plus 2 equal to X plus X square. So X square plus X minus 3X minus 2 equal to 0. That is X square minus 2X minus 2 is equal to 0. So this is the equation which I got. Is it clear up to this point? Are you able to understand up to this point? We have seen this type of question in capacitors, infinite network problems. Are you able to understand this? Yeah. Clear. Okay. See, so this is what? A equal to 1, B equal to minus 2, C equal to what? Minus 2. So what is the quadratic function? Minus B plus or minus root B square minus 4AC by 2A. So minus B by 2A. Then what? Plus or minus root B square minus 4AC by 2A. So if you solve that, if you solve the substitute the values, then if you solve that, you will get the answer X equal to 1 plus root 3. Because minus value is not possible. There will be two possibility, 1 plus root 3 or 1 minus root 3. So what is the total resistance we are getting? 1 plus root 3 for the x, unknown resistance. Now what happens? That x value we got as what? 1 plus root 3, that is what? 2.732. 1 plus root 3 is what? 1.73. So what is the answer of x? 2.73 ohm. Any doubts? I hope it is clear. 2.73. Any doubts? Yeah. Done, right? All of it. Next question. See, this is 5 ohm. Then this is 10 ohm. This is 5 ohm. 10 ohm. 10 ohm. 10 ohm. Upper 5 ohm. Another 5 ohm. See, this is A, this is B, this is C, this is D. What is the resistance between A and D? Resistance between A and D we have to find out. See, when it is given as resistance between A and D, you should understand that we are applying a cell or a battery between A and D. So the situation is similar to this. They won't tell you in the question. Now remember, current always flows in closed circuit. So when you connect a cell like this, what happens? There is no current in this 5 ohm and this 5 ohm. So I should rewrite the figure as 5 ohm, 10 ohm, 10 ohm, again 10 ohm, again 10 ohm. This is what D. See, I have not written 5 ohm, this 5 ohm and this 5 ohm because it is an open circuit. So no current flows through this section B and section C. So I have removed that. Now I have to apply the resistance rules. Now I can see that these two 10 ohms are in series. So this is 5 ohm. So this becomes what? 20 ohm. These two 10 ohms are in series, again 20 ohm. The combination is in series to 5 ohm. Now these two are in parallel, so it becomes 10 ohm. So what is the circuit? 5 ohm, then 10 ohm, then 5 ohm. So what is the total resistance between A and D? If you add all of these, you will get what? 20 ohm. Any doubts? Current engine supply, listen Sharanya, they won't tell you that they are supplying current. But you have to understand that if resistance between A and D means what? It is through that path only current enters. That is a common logic, or that is the logic you have to apply in this question. And suppose they are asking for what is the resistance between BC. Now what happens? Then you have to imagine that current is entering between the between 2 points B and C. Then A and D should be avoided. Is it clear? Please do it. Please note it. Then if, okay, please try to calculate the resistance between B and C. Please try to calculate the resistance between B and C and upload your answer. What will be the resistance between B and C? What will be the resistance between B and C? Twenty ohm. Same. Good. Next question. This is 2 volt. Again 2 volt. Then again 2 volt. Here it is 4.5 ohm. Now, what we have to find out? We have to find out what will be the current in this network. What will be the current in this network? See, current I is equal to net EMF by total resistance, right? So when you find out the net EMF, you should understand that first 2 cells are connected in the aiding way, but the third one is opposing. So 2 plus 2 by minus 2 divided by each, remember I forgot to write, each cell is having internal resistance 0.5 ohm. So what will be the total resistance? 4.5 plus what? Since each cell is having same internal resistance, total resistance is what? 0.5 into 3. That is, this 2 minus 2 gets cancelled. 2 by 4.5 plus 1.5, that is 2 by 6, that is equal to 1 by 3, that is 0.333 ampere. 0.333 ampere. Any doubt? Any doubts? Please note it down. Next question. Next. It's a network, a resistor network is given. This is A, this is B. This is A, this is B. A, B, C, D, E. A, B, C, D, E. We have to find out what is the resistance between A, B. What is the resistance between A, B? See, when you see this, no, you can't understand, but you can redraw this figure. See how I am redrawing. See, from A, it goes to a junction. From that junction to C, so from that junction to C, from the same junction to D also, there is one branch which goes to D. So that also I have drawn. And at this side, from B, it goes to a junction. From that junction to E. Okay, from that junction to E. So B2, this is B. Then it goes to what? E. So then what? E to C. E to C. Then E to D. Then E to D. Then what? Between them, C to E is there, E to D. Now between C and D there is a path. See, between C and D there is another resistor. So R. All are equal resistors. So what is the resistance between A and B? RO. Any doubt? See, at first when you saw this, no, you never thought it will be Wheatstone. But later we came to know that it is what? Wheatstone. Any doubts? Any doubts? Please note it down. Next question. Noted. Next question. Two point charges A and B of magnitude 8 into 10 raised to minus 6, 8 into 10 raised to minus 6 coulomb, and minus 8 into 10 raised to minus 6 coulomb. Placed at a distance of, placed at D distance apart. D distance apart. The electric field at the midpoint, electric field at the midpoint (6.4 into 10 raised to 4 Newton per coulomb). 6.4 into 10 raised to 4 Newton per coulomb. electric field at a midpoint. Find the distance. Find the distance between charges A and B. That is our task. So it's a dipole because first one is 8 into 10 raised to minus 6 and the second one is what, minus 8 into 10 raised to minus 6 coulombs. And the separation is what? D. Now at the midpoint, due to E plus Q repulsion in this direction, at the midpoint due to E minus Q, electric field is in the same direction. So at the point O, let the midpoint EO is equal to what? E plus Q plus E minus Q, because both are in the same direction. So what is the electric field equation? We know that electric field is equal to what? 1 by 4 pi epsilon naught Q by R square. So here I should write 2 into 1 by 4 pi epsilon naught Q divided by R square. So instead of R square, I should write what? D by 2 the whole square. I hope that is clear. So it becomes what? 2 into 9 into 10 raised to 9 into, what is the charge here? 8 into 10 raised to minus 6 divided by D square by 4 is the electric field. What is that electric field? That is given 6.4 into 10 raised to 4. Now what you have to do? You have to solve it for D square. So if you solve it for D square, you will get D square will be, if you solve that, D square will be 9, then D will be 3. If you solve that, D square will be 9 and D will be 3. Do it. Any doubts? Is that clear? The total electric field is given as what? 6.4 into 10 raised to 4. Why I have taken 2? Because both electric field due to plus charge and minus charge in the same direction. So I have to add them. Is that clear? Manasilayo? Yeah. So, thank you students. I am stopping. Thank you students. Enjoy your weekend. Thank you.